Okay, so I've been looking at wearable technology for firefighter health, safety, and well-being, and today we'll look at specifically how firefighters explore their thermal environment. So firefighters frequently work in a hostile environment. Conditions are typically hot, dark, confusing, and sense making is further hindered by heavy protective equipment and the insulating gear that they have to wear. Um, and further complicated by the tasks that they have to carry out whilst there. Um, it's pretty well understood now that this combination of the environmental temperatures and the activities that are carried out combine to impose heat strain on the firefighter. This has been shown to have long-term impacts on the heart and the immune system, and in the short term can impact cognitive abilities. This in turn can affect their sense making. So to counter this, firefighters are trained to read the thermal environment. They spend time in simulated environments where they watch fires develop and experience the conditions they can expect to encounter in real life. They train to look, listen, and feel for signs of danger. And they also use technology to help them make sense of this environment. Thermal image cameras provide sensory augmentation. They help firefighters navigate in smoke and darkness. They help them find rescue victims. They help them see the sources of heat and fire. But there may be a problem when we think about how we perceive temperature. So thanks to our sense of touch, we can tell the difference between hot and cold, and this protects us from the harmful extremes. But the same temperature doesn't always feel the same. If you think about the objects in your bathroom, the mat and the tiles, for example, they should all be about the same objective temperature. And it's the same in your office that you're sitting in now. The metal desks or the legs of the desk and the wood surface should all have reached the same temperature. But the temperature that you sense when you step on the tiles is very different from that of the mat. When two objects are different temperatures, heat flows from the hotter one to the cooler one, and it's this rate of flow that determines how we perceive the temperature. The tiles feel cold because they're good heat conductors and they pull the energy from our feet more quickly than the cotton in the mat. So our perception of temperature is based on how heat, or more accurately, how energy moves. And we call this heat flux. And we can see the same effect in hot environments. For example, when someone puts water on the rocks in a sauna, it quickly feels hotter because the water molecules are really good at absorbing energy. And this makes water a great conductor of heat. So huge amounts of energy are pulled from the hot stones as the water turns to steam. And when it turns back to water vapor, it conducts that energy onto any cooler surfaces that it touches, and that includes us. Firefighting relies on energy transfer from hot places to cooler ones. Every time a firefighter applies 1 litre of water to a fire, it takes over 2 million joules of energy to convert that into steam. The steam expands and condenses on cooler surfaces, reducing the temperature of the fire. But just like the sauna, this can make the firefighter feel hotter. And in 2015, researchers at the Fire Service Institute in the University of Illinois decided to look at this more closely. They noticed that there'd been a spate of firefighter deaths in training. In a number of cases, the training had involved live structures, or in other words, derelict buildings, or involved real-world furnishings that they had used as fuel. They were concerned that firefighters were seeing fires that looked similar to the size to what they experienced in training, but were exposed to much greater heat flux when confronting real fires. It seems that the materials and gases produced from the furnishings were much more effective at transferring heat energy to the firefighters. And this transfer of heat can lead to rapid cognitive decline and cause real difficulties with decision making and performing physical tasks. Firefighter Stephen Hunt died at a fire in Oldham Street in Manchester. He and his teammate were exposed to high temperatures, had difficulty summoning help, became disorientated and lost in the building. Stephen's teammate described how he recognized the need to press the emergency button on his distress signal unit to summon help, but that he simply couldn't manage to do it. He was unable to press that yellow button on the device in the lower left. They were only rescued after the automatic distress signal activated and nearby firefighters came to their aid. So how do we make things safer for firefighters? The Illinois researchers are now using things like bespoke wearable sensor packages and advanced physiological monitoring to explore the firefighter's thermal environment. But this seems like a long, long way off from providing a safety system that helps firefighters on the ground. Perhaps there's a breakdown of communication between the designers, the researchers who study this, and the firefighters that use the gear and do the work. And I think practical solutions will only be developed when these groups start to work together. And just as a quick example, here's a proposed solution using augmented reality, but it's pretty much just an Instagram filter applied over the traditional thermal image that's on the right. I would question whether it's bringing anything new. Is it an improvement, or are we actually losing context and data by applying this supposed solution? So I guess my main thing is I'm looking for advice from you guys to see where we go next and how do we bring these solutions to the firefighters on the ground. So thank you, and any questions?